In this video, we're going to cover section 2.6 on the derivatives of a to the x and log base a of x. This is the last section in chapter 2. So our objectives in this section are to learn how to find derivatives of functions that involve a to the power x and to differentiate functions involving log base a of x. Remember, when we've talked about log and exponential derivatives before, it was that number e to the power x and then the natural log, which was log base e. So this is just the more general form of differentiating functions of any base. All right, so theorem 12 is the derivative rule for the exponential function a to the power of x. Says the derivative with respect to x of a to the x equals the natural log of a times the function a to the x itself. Remember when we had e as the base, the derivative was just itself, which is e to the x. But when that base is not e, we still have the original function, but then we have to multiply by the natural log of a. The natural log of e happens to be 1, so even if the base were e, this formula is still going to work. All right, so let's try an example. Y equals 2 to the x. So utilizing that formula says our derivative should be 2 to the x times the natural log of 2, or you can put the natural log of 2 in front. So it's the natural log of the base multiplied by the original function itself. And that is it. You can't multiply these 2's together. This 2 is part of the argument of the log, and this 2 has a power of x attached. So that is just, you're done. All right, part B, y equals 1.4 to the power of x. Basically the same thing. 1.4 to the x is the natural log of 1.4 multiplied by the function itself, 1.4 to the x. All right, so part C shows us what if the exponent is not just x? What if it's another function? Well, this means we apply the chain rule. So we start the same way as before. We start with the base is 3, so we start with natural log of 3, just like we started this one with natural log of 2 and this one with natural log of 4. So we still start with the natural log of 3, multiplied by the original function itself, 3 to the power 2x plus 1, but because the exponent is not just x, the chain rule applies here where we also then have to follow this by multiplying by the derivative of the exponent. So the derivative of this exponent would be 2. So we get the natural log of 3 times e to the power 2x plus 1 times the derivative of the power is 2. So all they've done here is just move this constant 2 to the very front of that whole thing. But that's it. This 3 is inside the log, so it cannot get multiplied by the 2, so it's just 2 natural log of 3 times 3 to the power 2x plus 1. All right, here are a few more. So part A, y equals 5 to the x. Should be natural log of 5 times 5 to the x. So the derivative y prime, natural log of 5 times 5 to the x. B, this one should be natural log of 4 times 4 to the x. All right, and then C is going to be another chain rule. So we're going to start with the natural log of 7 times 7 to the x squared, but then you're going to have to multiply by the derivative of the exponent, which is 2x. So you get the natural log of 7, 7 to the x squared, but then the derivative of this power is this 2x. And again, they just push this all the way to the very front of the answer. Everything else stayed the same. This simplification right here comes from a log property, noticing that x just stays in front, but if you have a 2 multiplied by natural log of 7, one of those log properties says that coefficients can be brought up to be exponents. So this coefficient in front, if you bring it up as an exponent, this becomes the natural log of 49, 7 to the second power. You don't have to do that step. This is fine as an answer, but it is equivalent to that answer. All right, our next theorem, the derivative with respect to x of log base a of x. So if this was natural log of x, the derivative was just 1 over x. So for a different base, log base a, it's 1 over the natural log of a times the 1 over x. Or in other words, 1 over x, but also multiplied on that bottom is the natural log of this base number. All right, so finding the derivative, y equals log base 8 of x. Y equals just log of x, that's a base 10 logarithm. And then we'll do log base 3 of x squared plus 1. That's on that one, we're going to need to use the chain rule. And then on part D, x cubed times log base 5 of x, we'll have to use our product rule. All right, so for part A, derivative with respect to x, log base 8 of x. Just by the formula, 1 over natural log of 8 multiplied by the 1 over x. For part B, log of x, meaning this is, remember, the common log, which is assuming base 10. So we have to do 1 over natural log of 10. We just have to know that's a base 10 log times the 1 over x. All right, the third one, we have to use the chain rule. So it's the 1 over the natural log of 3, 3 was the base, times 1 over, instead of x being inside, it was x squared plus 1, so 1 over all of that. But then since this is not just x, the derivative of this is the chain rule part where we multiply by the 2x. So 1 over natural log of the base, 1 over the inside of the log, and then times the derivative of that inside. So we end up with the 2x on top, natural log of 3 times x squared plus 1 on the bottom. All right, and then the last one we have to use the product rule because it's a product of two functions involving x. So x cubed was the first function times the 1 over natural log of 5 times 1 over x is the derivative of log base 5x plus the second function log base 5x times, and then the derivative of this first function, the derivative of 3x squared, of x cubed is 3x squared. So it's the first function times the derivative of the second plus this is the second function times the derivative of the first, and that's just how the product rule works. By this point, we should be recognizing when the product rule is necessary, and when the chain rule is necessary, and when each of those rules we talked about are needing to be used. So this first term can be cleaned up. This x on the bottom can cancel one of the x factors in the x cubed. So if I take x and cancel it here, it cancels one of these, leaving x squared. And then otherwise, you just have natural log of 5 in your denominator left, plus, and then this one, again, we're just going to move this to the front, 3x squared, and then log base 5 of x. Again, this x is part of the argument of log base 5, so you can't multiply this 3x squared by this x. This, I probably would have put this in parentheses just to make sure that it's clear that that's separate from this part. All right, so let's try a few more. Log base 2 of x, negative 7 log of x, x to the 6 log x, and log base 8 of x cubed minus 7. So you may want to pause the video right now and try these on your own just to make sure that you understand what the formula is and how it's used, and then you can press play to check your answers. All right, so log base 2 of x. Just basic formula, 1 over natural log 2 times 1 over x. Negative 7 log of x. Remember, this is a base 10, and this negative 7 is just a constant multiple, so you just leave it there. You just leave the negative 7 in the front, 1 over log base 10 times 1 over x. You only need the product rule when you're multiplying both functions you're multiplying both involve x. If one's a constant and the other one involves x, you just leave the constant and just multiply that negative 7 by that derivative. All right, this is the product rule. So you would have started with x to the 6th times 1 over natural log of 10, 1 over x. That 1 over x will eventually cancel and give you natural log of 5 over natural log of 10 for that first term. Plus the log of x is the second term times the derivative of the first, 6x to the 5th. So they've cleaned this up a little bit. They've divided, so that initial x to the 6, 1 over ln 10, 1 over x part, that x has been canceled into this 6th power to leave the 5th power. And then part D is going to be a chain rule. So we're going to start off here with 1 over natural log 8 times 1 over x cubed minus 7, and then we'll multiply by 3x squared, which is the derivative of that inside. Oops, I guess they simplified up here before moving on. So here notice they factored out an x to the 5th. That's fine if you want to, leaving just 1 over natural log of 10 plus 6 log x. All right, so we have 1 over natural log of 8 times 1 over the inside of that log, x cubed minus 7. But since that inside part is not, right here, is not just x, the chain rule needs to be used, and this is the derivative of that inside, 3x squared. So that just merges together as 3x squared on top, natural log of 8 times x cubed minus 7 on the bottom. Okay, so these are all examples of logs and exponentials with product and chain. You could also have a quotient. So if you have a fraction and it involves, you would just use the quotient rule, and as you do it, apply your log and exponential rules. All right, but that's really about all that there is in this section. There are no word problems. All right, so here's our summary. Following rules apply when we differentiate exponential and logs whose bases are positive but not the number e. Derivative with respect to x of a to the x, natural log of a times a to the x. Derivative with respect to x of log base a of x, 1 over natural log of a times 1 over x. Okay, and that is the end of section 2.6, and that concludes the end of chapter 2.